Welcome to the next video in the GaneshaDx tutorial series. This time we're going to talk about textures. We're going to talk about what textures are, how they're formatted, how palettes work, what UV maps are, all of that fun stuff. And so let's go ahead and just get started. I have opened up already map 075, which is the volcano. The reason I've chosen this map is because we have normal static textures that you see in most maps, as well as animated textures, including UV animations and palette animations like on these lava flows. We will look at each of these types, and we'll also talk about all of the theory behind texturing. So the first thing that we want to do is I want to show you that I have moved all of the map 75 files, including the GNS, into its own folder called Texture Tutorial. And the reason for this is because I'm going to be adding files to this directory and it's easier to manage altogether. When you're making custom maps, it's a pretty good idea to have all of the content for one custom map in its own directory folder. So let's get started. First, if we click on the tab up here that says Texture, we'll get a new window that pops up, and it looks a little scary. There's a lot of details on here, but after we've gone through this, it'll all make sense. As we click around, we'll see that there are highlights over here. These are the UV maps for these polygons, which we'll discuss in a minute. First, I want to talk about this little window. You can drag it around like I just did. You can also resize it. No matter how you size it, it will always resize into a perfect square. And you can, oops, I have accidentally clicked that polygon. If you scroll your mouse wheel in and out, you can zoom in and out, and you can right click to pan it around. Additionally, you can click on any of these and it will click and select the associated polygon with that UV map. And if you hold your left mouse click, you can drag it around, as well as drag around the vertices that make up the UV map. One more element of this window is that we have two options over here. We have show unselected UVs, so if we check that, we'll only show the selected UV map for the polygon that we have selected. You can see as I toggle this, it'll show the UV map for every polygon, and here we'll show only for this one polygon. The other option is highlight selected polys, and the reason for this is that sometimes you want to be able to see what's going on in the texture. As I move its map around, you can see that the pixels that make up the surface of this polygon are changing. It can be a little hard to see when it's highlighted, so we can uncheck that, and we're better able to tell what's going on with those exact pixels. I'm going to go ahead and reload this map because we have changed some of the UV maps, and we're going to talk about exactly what UV maps are. Every map has one texture image, and that texture image is broken into little pieces, and each of those little pieces is mapped onto individual polygons. If every polygon had its own texture, that would be a lot of texture files. For example, if we look at our polygon list, we can see that we have 113 textured triangles and 268 textured quads. If every one of these polygons had its own image for its texture, that would be about 380 different images. It gets unruly. For one, it's taxing on the engine, and for two, it's taxing on you as the designer to manage so many files. So, in 3D modeling, we typically deal with one image for an entire model. And the same is true in Final Fantasy Tactics. We have one image for our texture. Now this image is broken into 4 pages. You can see here we have two main properties, texture page and texture palette. We'll talk about palettes in a moment, but for now, texture page is a value from 0 to 4. And you'll see that as I click on, let me go ahead and uncheck this box so that we only see our selected UV, allowing us to actually look at our texture image. You can see that when I click on this polygon, this is the texture that we see. However, if we click on, say, this one, it changes its entire graphical set. And if we click on this, we have yet another graphical set. Additionally, if we click on this polygon and then click on here, it's the same image. You can see these rocks here and all of these rocks. It's the same image, but it's colored red. This is because a different palette is being applied. We'll talk about palettes in a moment. But first, I want to show you exactly what's going on with the texture. So I'm going to export this texture. It is called, by default, map075.8.png. And like we discussed in the introduction to Ganesha tutorial, we have all of these resource files. Map.075 or map075.8 is 128K, which we know is a texture file, and that is the resource file representing this texture. And so our file name by default is that same file name for the resource with .png appended onto the end. So we're going to go ahead and hit save. We get a message up here that says that the texture has been exported. And when we look in our directory folder, we have a new file called map075.8.png. When we open this up, we see this black and white image that is really tall and not as wide. We're going to go ahead and open this into Sprite. You can also open this into Photoshop or GIMP or even Microsoft Paint if you want. I use Sprite because, for one, it's cheap, 2, it's powerful, and 3, it's got a really solid workflow for dealing with exactly this kind of work. I do recommend it. It's about $15. Sometimes you can get it for $10 on sale, and I strongly recommend it if you want to be serious about texturing within Final Fantasy Tactics. So, what do we got here? First of all, this image is 256 pixels wide and 128 or 1024 pixels tall. If you do the math, this actually is a 256 image, another 256 image, a third 256 image, and finally a fourth 256 square image. So we've actually got 4 textures in one. This is the way that Final Fantasy Tactics deals with it, is it combines 4 total textures into one strip. And it's controlled through this property here, texture page. And you'll see if I change texture page to 1 that this image has changed, and we change it to 0 and it's changed yet again. We'll change it back to 2, which is what's supposed to be. And if we look here, we'll see that this is what we saw. So why is this image in black and white? Well, that's because all texture images for Final Fantasy Tactics maps are in black and white. They are 16 colors. There's no more than 16 colors. And each of those 16 colors is mapped with a palette. So let's take a look at our palettes. If we click on Edit Palettes here, we can see 16 palettes. Index starts at 0 and goes down to 15, making a total of 16 total palettes. When we click and look at our polygon, we see that this is set to texture palette 0, this is set to texture palette 1, and most of these are 0 or 1. Yeah, so this is 0, but if we go in here and we change our texture palette, let's turn off the highlighted surface so you can see. Texture palette, if we change this up to 1, we see that it looks like the lava color. Change it to 2, and we get some interesting colors down here. Same as with 3, there's like a bluish color, and you can see up here that this has updated every time I change the texture palette. And you can see that texture palette 1 is mostly red, texture palette 2 is mostly gray with some reds, and if we look at our palette list, that's exactly what we see here. Texture palette 0 is mostly gray with a few reds, and texture palette 1 is mostly reds. So what's happening is that each index of our palette, each of these 16 colors, maps to one specific shade of this gray in this black and white image. So if we were to take our magic wand brush and turn off contiguous, it will select all of the pixels that match the exact same color that we clicked. And when we click that, you see that all of these match. This exact shade of gray is used a lot throughout this image. And in fact, the same with this one, this one, this one, and so on. Every single color is used many times. Like I said, there are only 16 total colors that make up this entire image, and each of our palettes is 16 total colors. So that's what's happening here, is each polygon chooses which of the 4 texture pages to use, and then chooses one of the 16 palettes to use. Now, how do we know which pixels to actually represent? Since we're using one image for every single polygon in this scene, we need a way to map parts of this image to this polygon, and that process is called UV mapping. If we click on this, we'll see up here the UV properties. We have the 4 vertices that we're familiar with, red, green, blue, and yellow, and each of them have 2 coordinates. There's a U coordinate and a V coordinate. Now we can just replace this mentally. U is X and V is Y. U is how far across our image is, or our UV map is, and V is the vertical placement. So if I take this and I move it left and right, you can see that the U value is changing rapidly. If I move it up and down, you can see that the V value is changing rapidly. Let's get this back into its place. Actually, let's go ahead and just reload instead of trying to figure out exactly where that was. We go back to texture. And now if we click on these various polygons, you'll see that the UV map for each polygon is different, and that it matches what we see on the polygon itself. We can pull this up to make it a little bit clearer. We can see that this polygon uses these pixels here. And if I move these vertices around, you'll see that the image is moving and stretching. We can pan it around, and it's almost like this is a viewport. Like this polygon maps to this space. And if we make it bigger, then we have more pixels on that polygon. See, it's got a higher pixel density than the ones around it. You can see how big these pixels are versus how big these pixels are. So let's go ahead and reload again to bring it back to our previous state. Now also, each of these vertices maps to these. So as I move the yellow vertice around, you'll see that the pixels around the yellow vertice on the polygon are changing, but not the ones around the green, blue, and red ones. And then, of course, the same would be true with, say, the red polygon. Now, we get some distortion. See how distorted and weird this looks when our shape of our UV map doesn't match our polygon shape? What we want generally is for these two to be the same shape, including the same ratio and same dimensions. So that's what UV maps are. Every single polygon has a UV map, and a palette is different and unique to that polygon. Now, some of these are animated. We will take a quick look at animated textures right now, just so that you have an understanding that they exist and how they work generally. But in a future video, we'll go over the actual the details of animated textures. But if we click this button here that says Edit Animations, we click that and we can see that we have a list of up to 32 animations that we're allowed to add. So let's click this first one that says UV Animation, click Edit, and we can see the frames and the canvas. We'll talk about what canvas is, but these are the frames that make up this animation. As you can see, we have this bubble that spawns here and pops, spawns and pops. And when we look at this, we see the bubble starting to form, getting bigger, popping, splattering out, and then it repeats. Goes right back to that state. So that's how UV animations work. And palette animations are very similar in that we have a starting index, in this case it's 0, and a total frames, so it'll do the first 5 frames, 0, 1, 2, 3, and 4, and it'll cycle through these frames, applying this animation every 8 frames. It'll apply the next frame in that animation, so it'll start on frame 0, or rather palette 0, and then after 8 frames of gameplay, it'll go to palette 1, and that's what we can see here, is that the palette is being updated. If we look at this in our image editor, let's see where this is. So this is texture page 2, and it's down over here. We can see that there's this like it's this space here, and you can see that there's these kind of spiky shapes that go out. What happens is that, according to this palette, or to this palette animation rather, is click the wrong one, is that of these colors, all of them are this kind of darker red, and then one of them is a lighter red. And so the first time, all of these will be this red, and then this one will be the lighter red. These are not accurate colors. So this will be one palette, and then the next time this will be that color, and then that will be that color, and so on. Because remember, each of these colors, each of the 16 colors that makes up this image, will be mapped to each of these 16 slots in our palette. We'll talk more about this when we get into the workflow for managing textures, importing textures, and all of that. This is mostly just an overview so that you understand what there is that you can do. Only thing really left to worry about here is this property here that says texture is lit. And what that means is that we have our lighting system. We'll talk more about this when we get into lighting, but our lighting will cast down on each of these textured polygons. If you uncheck this, your polygon will no longer be affected by that light, which doesn't mean that it'll be shadowed. It'll mean that it's not affected by light at all. It won't have shadows or highlights or tinting shades depending on the light. It will be the exact color pixels in the palette. We'll talk more about that in lighting, but that's what this property is. Sometimes you might run your game and find that one of the polygons stands out more than the other ones. And typically the reason is because your texture is not being lit. Other than that, there's not a whole lot to talk about. I think that does cover our overall view here. Oh, one last thing I actually do want to talk about is exporting the UV map. So let's go ahead and show Unselected Uvs, turn that back on. And we can see that every polygon has its own UVs. Okay. Sometimes you want this in your image editor. So let's export just the UV map. We will export it to our directory, texture tutorial, and it's got a file name filled in just like with the texture image that start with map075.8.png. We do the same thing, map.075.8.uvmap.png. So we'll hit OK and save it. And if we open this up in our image editor, what we get is an image that is the same size as this, but all it contains is the outlines for all of the UV maps, which you can take this, you can select the entire image, press Ctrl+C to copy, and then paste it right on top of this image, and you can see where all of these UV maps line up. This will be very useful when you go to start making your own maps. Again, we'll talk more about this when we get into the workflow tutorial. Other than that, that is an overview of textures, the philosophy behind them, and generally how they work. Thank you, and I'll see you in the next tutorial.